air traffic management services, not only in what is controlled airspace today, which is constructed around where airports are, but everything really successful ones is the FAA's land system. And I just put a summary here of what this is. You see on the top, it's basically a 10-month process from getting your application in as a USS service provider for saying, hey, I want to provide this capability. Then the FAA vetting you as a company, you implementing all the operating rules that are listed on the left. So you have to basically, ingest a whole list of data. You have to make sure that all the functions work according to what they are specified. And then you have to go through a technical interview, which in the end culminates in a checkout process. So a bunch of people sit in the room and you demonstrate your product and people ask you questions and you have to demonstrate that everything works according to what the intent of the design was. And then you are approved. And then FAA can go ahead and issue new operating rules. And then you have to, again, walk through the same process. So you demonstrate you comply with the new requirements as well. So this works. The same process can be potentially replicated for other functions. This just provides USSs the ability to provide airspace authorizations at low altitude to operators, but potentially for something like remote ID or other UTM functions, there would be something similar in place, and lots of lessons learned currently, or definitely from the FAA in this. One thing that in the context of remote ID is I think very well worth noting is that when we talk about UAS and operator registries, USSs actually also should have a role in this, because if you want to extend a trust framework, like a chain of trust of identities from the operator to all the drones, to in the end the service providers and the services that are provisioned, there need to be digital interfaces between all of them. But I want to just keep this as a side note here. And move quickly on to the other category of services. USS is providing services to operators. And that's an interesting situation. So here's a typical flow chart of what it means today if an operator wants to, for instance, file for a SORA-based operation. So maybe he wants to fly beyond line of sight, or wants to fly above people, or has some kind of heavy aircraft, or does drone delivery mission, or whatever. In most countries, what that means is maybe you have industry standards for those types of things, maybe not. But you would then basically, as an operator, develop the safety case for your operation. And if you are now using services by a third party, for instance, a USS, then this creates a bit of a problematic situation, because you have to now appear in front of the competent authority who would approve your operation. And as the operator who seeks approval, you need to be able to basically substantiate all the safety requirements from your full system, which includes all the third-party services that a USS might provide to you. And that's not scalable for the USS, because now we have to give all sorts of proprietary information out to operators who seek approval and probably don't want to do that. It's also not really scalable for the authority who's evaluating those requests, because now we have non-standardized safety mitigation solutions that are different for each and every single operator. And so the workload that this means for someone at the authority reviewing the safety case is insane. It's not sustainable. So here comes one amendment that is currently being worked on at JARUS, the Annex H to the SORA. And this is also where I borrowed this chart from. Thank you, Jared. It lays out the relationship between what ideally needs to happen between an operator who wants to fly missions and get these missions approved, the competent authority who is reviewing the safety case and approving it eventually, and the USS who is providing on the one side a service to the operator under a service level agreement. Right? So you pay basically as a monetary exchange between the USS and the operator. for providing services and in return getting money. Now, what we also want to establish is the approval process between the USS and the competent authority, such that in the end we can create a situation like this, and we split the stream up in two different streams. The first one is the USS getting approved for providing certain safety services by the authority, and this happens only once, and it's then probably based on industry standards. And then those approved services can be used as input to every single operation that now operators are putting into their safety cases. But because the authority has already reviewed the safety case of the service by the third-party USS, there is now a really more efficient way for the authorities of approving these operations. So it solves a lot of problems, and in the end is exactly what the model of, for instance, suppliers of flight management systems in aircrafts are also doing. You have a certain component that is certified on its own, and then if you build the aircraft, all you have to do to achieve airworthiness to the aircraft is to make sure that your integration of this certified component in the larger aircraft system is done according to what the requirements are. But the manufacturer of the aircraft doesn't need to substantiate all the safety requirements of every single component. So that's the situation we want to create, and the USS approval processes are really core to that. So in conclusion, those two models are fairly different in terms of who services are provided to, but the requirements in terms of approval processes are very similar. And so one very promising example is the FAA's capability of LANs, where this has been done for almost, is it close to 3 years now? 2 years, I guess. It's active at hundreds of airports. There's tens of, in the order of 15,000 operations approved every month under this model of having an organizational and functional approval of USSs. And this is really something that can be rolled out immediately in many, many other regions. And somehow this hasn't happened yet for various reasons. But it should be more put into the focus in my view. So in the future, the next step would likely be getting USSs to be approved remote ID service providers. And then we'll see what the more complicated safety requirements around the SORA would turn up, because obviously we're in this domain moving a little bit more into services that are actually used for mitigating safety risk, meaning then if they don't work, there might be people at harm instead of a land service which really does not have those requirements. So if a USS doesn't work and the system is down, no one is at harm. The system just doesn't work and you can't get authorizations. And the harm part is mitigated by other services around that. So that's the conclusion. Thank you very much. And back to the moderator. Thank you.
Thank you, Andrea, for your presentation. And also now to introduce a new speaker, Mr. Guru Kimchi, VP Amazon Prime Air. Guru, the floor is yours. Thank you.
Thank you. Good late morning. I appreciate it. Here we go. Excellent. I'm very happy to be here today because 2 years ago in Drone Enable 1, we spoke about the concepts that we like to demonstrate, and here we are a couple of years later. And I think we, as an industry, both sort of in corporations, researchers, regulators, and other stakeholders are now actually demonstrating in the real world that these ideas are possible, scalable, and implementable. And I wanted to maybe talk about sort of standards testing certification. I am saying certification, although what this certification specifically means may be different, just like my previous speaker mentioned. The challenge is pretty straightforward. The way we perceive the current ANSP centralized model, as robust as it is, and I completely relate to the fact that we board an airplane today and we fly anywhere in the world with incredible level of safety, and the role of air traffic management in that safety is very, very important. At the same time, that complex interplay of humans and machines in both the airplane and off the airplane is very expensive and very complex to scale, and there are some cases where there were failures in the system. Chicago Center in the US is probably the one that I usually think about, where it's very hard to build reliability into the current system. So the question is, given the growth of unmanned systems, will the current system as is scale in an economic and safe way? And we would posit that it doesn't, and we need to drive a lot more automation. And the question, of course, how do we make sure that automation is delegated correctly and does what it's supposed to do? And how do we ensure that the aviation authorities have the right oversight capabilities to ensure that they can manage the airspace, although they don't actually manage the operations in the airspace? And in a way, we have a big task. These standards that serve us today were essentially developed using the experience of almost 100 years of aviation. And UTM started about 5 years ago, roughly, and we want to have all these standards be completed, demonstrated interoperably, and in the market in the next 5 years. That's aggressive, that's challenging, but I think if you look at the rate of progress over the last 2 years, I'm very enthusiastic. Let's talk about some system requirements. First thing, it has to be real-time, it has to be secure from day one, and it has to have an automated capability to manage the topology of the network. We heard before about what has to be centralized and what has to be distributed. Clearly, the role of setting policies, how the airspace must be administered is a centralized activity. Who is allowed to operate is a centralized activity. But mission management itself is safety critical and has to be distributed, so there is no single point of failure. And every time we talk about a centralized system, think about the central point of reliability also means that you have a single point of failure. And we already have the experience that shows that that's not a good idea. That's just not a robust architecture. We'd like a system that can be adapted on a global scale, has to be interoperable and interconnected. This is something we got used to. We open our laptop anywhere in the world, and we connect to a local network, and we talk to services anywhere, regardless of where we are. We have personal and device mobility and network mobility, and the same concepts that allow the same systems to interoperate regardless of where they are and which environment they operate in is something that we want to ensure remains. It's very important that we rely on existing technologies and mechanisms. They relate to, for example, using Wi-Fi where it's available, where it's appropriate, using standard established security protocols instead of inventing our own for this domain. In a way, our phone, right, the phone that you all have in your pocket and I have up here, is more secure than any aerospace system in deployment today. And that's unnecessary. These technologies are essentially off the shelf and we should just use them. Use them appropriately, use them responsibly, but just use them. Whatever technology we operationalize has to be credentialed. And I'm using the word credentials because it can be open to interpretation. Does it mean formal certification by a single authority? Does it mean there are a set of testing providers that are credentialed to credential other operators? Are there testing and certification standards that people will self-comply with? These are all options. We should talk about them, but we should agree on a common approach to what does it mean to be certified and what does credentialing means. And this is key because we tend to think about unmanned systems, these small drones that you see flying around, but the range is increasing every year. And the larger systems are being autonomized at maybe faster velocity than some of the smaller systems because the risks are higher and the requirements of beyond line of sight are higher. And we'd like a system that can be certified anywhere in the world and then interoperate and operate anywhere in the world, both in country and across member states. Again, I'll use the example of the phone. I can This is an American phone, and I turned it off in Canada, and it just worked. I'd like to take equipment that was built in any country, turn it on in any country, and as long as it complies with the global regulation, it should just work. Now, of course, if it doesn't comply, it should just not work. And how do you guarantee that is very, very important. Let's talk about two critical capabilities. One is remote ID, one is the Federated system. We'll start with remote ID. Generally, remote ID, I think you've been hearing about the broadcast kind of remote ID where drones talk to each other directly, generally over either Wi-Fi or Bluetooth. My own favorite is Wi-Fi because it's just a software upgrade and most drones don't have Bluetooth right now. But it's something for the industry to come together and agree on. It's very important that we have a single standard. If some drones speak Wi-Fi and other drones speak Bluetooth, and if some devices listen to Wi-Fi and other devices listen to Bluetooth, then the network will be fragmented, and we didn't actually build the right solution. It's very important we pick either both modes always work, or we pick one that we know is the mandatory one, and the others are optional. And this is important. It does not require a network. I heard in a previous session that some tasks around remote ID are delegated to network mode and some for broadcast. I tend to think about them as parallel. You always broadcast, and if there's a network, you always use the network. You want as many sort of layers of safety that you want in your system in announcing your position and intent. Obviously, network ID is great because it gives you a strategic view of the airspace and allows people who are beyond line of sight, beyond RF line of sight, I should say, to be able to perceive what you're doing, what you're about to do. But there are many cases where a network is not available, not only in remote places, close to structures, the network may not be available, close to the ground, network may not be available, and being a robust system that has both capabilities at the same time is very, very important. In the context of inter-USS or inter-UA, clearly they talk to each other either through the network or directly. In the context of a third party, law enforcement, for example, who's asked to see who's that drone and are they supposed to be flying over my accident, if that's the example. They require the role of a user display provider, USS, which is something that standards are actually covering right now, the ASTM standards. And I'm very happy to see sort of the work taking place in STM around it. Another recap, the Federated architecture, this is not a new idea. We spoke about this as far long ago as 5 years ago. I'm sort of super happy that over 5 years, every presentation we've seen today has the word federation on it. This is great because this is not a sort of an obvious architectural construct, and the fact that the industry is thinking deeply about it is very, very important. How exactly we dial that, what is a central authority role and what is delegated to this federated architecture is an incredibly important question that we all have to address, and we have to make a set of decisions that will apply to all of us. The key point is, in the system, every drone will talk to the USS. Now, I think a lot of the architectures right now assume that the role of the operator and the role of the USS are distinct, and that's true to a lot of cases. Some of you may be using a hosted email provider for your email, so you are the operator of your mail, if you will, and you're buying services from a mail provider, the USS for email. But there are many large organizations, and I'm sure a lot of you participate in them, that the organization runs its own infrastructure for its own users, and then these roles are combined. So making sure that the architecture allows this composition and decomposition of these roles and responsibilities is very important. Let's talk about what these roles are. Manage the US operations and interactions, connect to the network. The network has to be aware of your capabilities or lack of capabilities, both nominal and off-nominal, and how you expect to interact with it. What is your concept of operations? What are your performance capabilities? What are you actually planning to do? Real-time on-demand flight planning. This is key because we have flight planning today in ATM. It's not real-time or on-demand, and critically, it doesn't do time-based replanning. And that's a capability that hopefully, once we prove it works on unmanned systems, we can learn how to do it for manned systems just as well. The algorithms should be very, very similar. Let's prove them at low altitude, extremely high altitude, and then slowly make the technology available for the rest of the airspace. Federated with other USSs who operate in the same area. That concept of an overlap The fact that you can have multiple operators, multiple USSs sharing the airspace is very important. Again, the inspiration is our cell phone network. I'm using T-Mobile and I'm roaming with, I don't know who I'm roaming with right now, and I can place phone calls to any other phone, regardless of what service provider they leverage. This is not obvious. It wasn't like that many years ago. We could only live within our technology boundary. We've demonstrated as a technological society that we can actually build these kind of inter-networked systems. And maybe the most important capability that the system has to provide is separation assurances, both strategic and tactical. The strategic sense is mostly networked, where USSs knowing their missions and other USSs knowing their missions and finding conflict can resolve it, but also tactical deconfliction that can be built on top of remote ID. And maybe I'll talk about it a little later. And I usually sort of for this sort of animation up, because it just shows a visual representation of the same architecture. I've shown it 2 years ago, exactly the same one. So my unmanned system aircraft will talk to my service because I'm both the operator and the sort of, I'm all in one shop, if you will. Then I deploy my own equipment. You may operate your own and you'll have your own USS, and that's perfectly reasonable. And the Federation concept is that these two USSs will speak standard technical protocols and interoperate. Obviously, the ANSP, the Aviation Authority, regardless of your local terminology, has a critical role to play around setting policies and ensuring that critical information is available to the network. There are cases where the ANSP may also provide direct USS services, let's say for a military application or some government function. So that's completely, it's the same protocols. How you use the protocol is sort of your own decision. And I think the role of a USS as a service is incredibly important. Not everybody has the resources to deploy their own network capabilities, and there should be a range of service providers available to anyone from the smallest real estate photography person to the largest operator who just simply doesn't want to deal with the sort of requirements to certify and operate a large USS. I think the concept of remote ID and vehicle-to-vehicle communications, which relies on remote IDs, is something that we have to spend more attention on. Once remote ID is available, drones can speak to each other directly, not through the network. I'm talking about the broadcast mode. Two drones can share their intent, and through that they can also deconflict if a conflict is discovered. And this is a tactical version of the same strategic capability that exists on the USS to USS federated interface. Now, I'll just switch screens on you, and I'll show the current abstract architecture of the telephone network that we all rely on. Guess what? Looks exactly the same. This architecture works. It works for billions of devices, for hundreds of countries around the world. We know the architecture works. This is not a risk. If anything, this is the lowest risk we could take in choosing an architecture for the future of aerospace. Let's talk about one specific example that usually comes up. Dynamic deconfliction. I'll actually use the same exact animation I used 2 years ago but in the end, I'll do something different. So in this case, you have two operators, their area of operations, or two USSs with two operators. Their area of operations overlap, so they share flight plans. In this case, the flight plans actually end up conflicting. So they run the same algorithm, deconfliction algorithm on both sides. It gives both them a result. It is now deconflicted, is clear of each other. They share it, run the same algorithm again, see that it's clear, and now they're free to perform. So you just keep iterating. You're dynamically resolving the issues until there are no issues. And the nice thing, nice sort of side effect of this architecture is that there isn't a central point of executing these algorithms. It truly is distributed, and it doesn't really matter if everything changes all at once or something changes. Notice as soon as the two of them are in that overlap area of operation, the two USSs will now share location data between each other, right? So as soon as they are in each other's space. And what's important is this is not just a concept. It was a concept 2-3 years ago. It's not a concept. This is one of the sort of demonstrations that Florian mentioned before. Under Cesar U-Space was the Sapphire Federated Interoperability demonstration. We had multiple service providers federating. We had an ASP participate, many players, both sort of directly with the USS and using USS as a service, all sharing the same airspace safely, including dynamic reconfliction, dynamic no-fly zones. This is a reality. Now, is this ready for prime time? Is it ready for scaling? Is it ready for productization worldwide? No. We have to finish the standards. We have to select the right performance choices in the standards. For example, Wi-Fi versus Bluetooth. That's an example of a choice that we have to collectively make as an industry. But is it risky to go down this technological path? I would say no. We've reduced the risk to the point where we know this solution is available to us. Now we can start to make some operational choices. Instructions requirements. Each USS will publish a portfolio of services. This is sort of the concept of themes comes in, right? Some USSs may specialize in data services, weather, traffic, terrain models, etc. Sort of cellular network coverage map, etc., right? It can be offline or online data. And others may publish services that are really deconfliction and airspace management services, which are more the classic UTM services. And these services are discovered by other USSs. And each of these endpoints implements a standard protocol, and that implementation has to be certified. That means that we have to test both the syntax and the sort of the structure, the interoperability of the system. Generally, it means you test at the API level and you test with simulation. You run large simulations with Monte Carlo, et cetera, between everybody who has an endpoint and has a system. And that tests both the implementation of the interfaces and the implementation of the algorithms, especially deconfliction behind the interfaces. What I would mention, which is maybe unique in terms of certification, is continued airworthiness. It's not sufficient to bless or certify or allow a USS to pass the audit. They have to continuously demonstrate that they are still in compliance. This can be done with simulation and by everybody running against each other and detecting failures when they're, again, syntactic or interpretation differences between different providers. Some of these protocols are incredibly important in terms of deconfliction. We cannot leave this open to interpretation of a local implementer. The role of an approved testing provider is really important. They can verify interoperability and compliance. We should define who these are. Are they USSs themselves? Is this like a delegated authority model? Is it the ANSP or is it the Aviation Authority? Different countries are taking different approaches. It should be clear, is it a third party that is delegated to verify the correct implementation of each USS interface? It's something that I think I don't think there's a right and wrong approach. We just have to all agree on a common approach and comply with it. And then I think probably the most important point is to ensure that once these standards are available, they're available cross-border and in-country. The only way we can make this system scale is by ensuring that any country can operate any of these systems without having to sort of create any additional burden. That's incredibly important. And again, I know we're talking about primarily very low altitude and very high altitude in the beginning. Over time, once we gain confidence in this approach, we can start to see where else in the system we can use this technology. I would break down sort of these interfaces that have to be tested, and I'll show also an architectural view of this in a second, into discovery. What are the endpoints? What are the capabilities? And then actual data exchange protocols, things like deconfliction. It's important to sort of break these cleanly. Discovery is clearly coordinated, not necessarily centralized, but centrally coordinated activity. Who is allowed to operate a USS and which specific endpoints are permitted to be turned on in a specific region is something that has to be approved. That approval process is centralized or delegated from a central authority. the actual operations of these endpoints, once they've been approved, can be distributed. And that's where, and it's also important that the approval process is offline. It's done generally once. The verification can be done periodically to ensure continued compliance and continued airworthiness. But it doesn't require the verification entities, regardless of who they are, the NSPs or the Aviation Authority, to be part of the critical chain of the operations, which is really where most of the cost and complexity is. Areas of verification that I think are especially important, how discovery works, especially in terms of spatial interactions. I have experience in other domains where if you don't very well define your sort of geodetic sort of systems and the code that does geodetic calculations, there's a lot of issues that can come across there. What is the volumetric performance and scalability versus latency, right? You don't want to operate a system that doesn't scale for the volume of operations it has to support and all the other operations in the area. And that's important because you have to be able to listen at least or subscribe to all other operators in your area of operation. So you have to know that it's not only scaling the system for your own use or your own customer use, it's scaling the system to the capacity of that region. And that has to be demonstrated and verified. The whole area of flight planning, conflict detection, and strategic separation assurance is incredibly important. How a USS does data retention, what are the national policies, international policies around flight data detection, especially cross-border. That's a very important area to deal with. How do you handle that data, who has access to it, etc. How do you handle responses to queries and concerns? And these can be online, when the system actually has to react and provide answers to, let's say, again, a local sheriff, a local police department. They're asking who is that drone flying, or were there actually complaints about unfair use of these systems, either by operators or between the USSs. It's completely possible that a specific USS implementation can do things that are unfair by overbooking its airspace or delaying responses to deconfliction commands. And we have to make sure that there's a sort of arbitration capability for the network. I think I'll save the most important for last, the formally correct interpretation of technical standards. The fact that you have a technical standards is incredibly important, but insufficient. We have to demonstrate that multiple independent implementations of these technical standards are correct against each other. Generally, in some technical organizations like the IETF, you cannot ratify a standard until you demonstrated two independently developed code bases against the same standard and prove that they can interoperate correctly by construction, by verification, by simulation. We'll have to come out with a similar idea here. And I think the most important one is these deconfliction algorithms. Everybody here is familiar with TCAS. It's inconceivable that you'll have different interpretations of the TCAS algorithms on every aircraft. It has to all be exactly the same. It's not open to interpretation, and that these have to be verified. From an architecture point of view, clearly the broadcast remote ID we think is a big enabler for the industry right now. That's an area that we should demonstrate interoperability. I love the fact that there was a demonstration earlier today. We should do a lot more of this. But the demonstrations are sort of insufficient. What we have to demonstrate is interoperability of disparate systems built by different vendors, and interoperability with different viewers, if you will. So we know everybody has access to both publishing the data and receiving the data. Clearly, sort of network remote ID is also very important where it's available. It's an and, not an or. The whole concept of using remote ID in broadcast remote ID for vehicle-to-vehicle deconfliction, I think, hasn't got enough attention yet. It's much easier than the network version of deconfliction because it's and we have the inspiration from TCAS to follow. So I think it's something that we should pick up. The whole, obviously, federated airspace management, flight plans, deconfliction, we just spoke about what I consider to be the core UTM services. How do you communicate TFRs, etc. Right? I'm using TFRs as the prototypical example, but there's a lot of data that changes, and whoever has the rights to this data and owns this data needs to make it available for all the operators in a given area. Clearly, the concept of themes, which you can do TFRs with themes, you don't necessarily have to do it the same way. You can change the airspace construct also. There is a need for a USS to aircraft protocol. That's not clear to me sort of how you build it. That's its own standard, maybe a third tier of standards that allow any drone to talk to any network. Think about this as the HTTP standard or the sort of core protocol standards allow any phone to talk to any network. I think that's very important, but there are cases where the interface between a drone and its USS will be proprietary, because that's obviously the remote ID won't be proprietary, but that vertical interface will be proprietary, and that's okay because the public interfaces are still shared. And I think the whole role of non-collaborative detect and avoid and what performance standards we write around it, and I'm saying performance standards and not technical standards, is something that deserves our attention. If someone says I have non-collaborative detect and avoid capabilities, therefore I can operate in the following scenarios, following sort of airspaces, how do you actually demonstrate that compliance? Who verify, who validates, who certifies these capabilities? So it's sort of, if someone can say pilot equivalent performance or better than pilot performance or all-weather performance, what does it actually mean? That's an area that probably deserves our attention as well. Closing, we need a system that's safe, economic, scalable, but critically interoperable. If we have a lot of standards without very precise definitions of how they interoperate, we'll end up with a segregated, segmented network, and that doesn't lead us to the safe outcome that we all hope for. That means harmonized technical and performance standards. Harmonized in the sense that all choices are documented, that we can guarantee that disparate systems can talk to each other. This allows you to establish trust with both the existing players and the new players. Everybody understands exactly what roles they can and they should play. And I think critically, that allows sort of the creation of testing and validation of these technical and interoperability standards, right? I mean, once we know what it is that we're shooting for, we can define the testing methodology and certification methodology that will guarantee that we're delivering against it. But the sort of step, the first step is decide the specific flavors and choices in order to make sure everybody can interoperate. And I'll thank you here. One of the things that, I don't know if, like, how am I doing on time? It's okay. One of the things we usually do, like, these are technical conferences, I love them, they're great, but sometimes connecting to the actual sort of mission is important. This is a concept of operation that's sort of our aircraft. The whole point of having technical standards that we can fly our missions and we'll interoperate in the airspace with anyone else who's flying their mission, which may be very, very different, and we can share the airspace safely, fairly, and efficiently. So I think bringing it home in a way to what does one of these applications look like, what does, is sort of interesting for me. I expect there to be a lot more unique aircraft in the future, and how we think about standards today has to accommodate for it. What we think about performance capabilities or the lack of performance capabilities in systems today, of all systems fit into a specific silo that is like we have aircraft that are Part 25 aircraft that are heavy and others that are not, and we have turboprops and we have helicopters. I think that will decompose into a lot more different kinds of aircraft that are mission specific. We started with a pretty conventional multicopter, and we end up with something that looked unlike anything else because our mission is specific and unique. We end up with an aircraft that was specific and unique, and maybe I'll show it to you just so you know what it looks like. So the shapes of aircraft that you'll see in the in the sky flying today, and what they do and what their capabilities are going to be unique. So we sort of have to make sure that the standards are flexible and plastic enough to accommodate them. And maybe I'll end here and just let this video play. Thank you.
Thank you, Gur. You touch a point I think we saw in all the presentation. Interoperability is key for this to work. So now our last presenter for this session, Mr. Reinaldo Negron, Head of UTM Von Wing. The floor is yours.
Thank you. Thank you, and I think we're officially getting close to good afternoon as we talk through it. I really appreciated Gur's ending of talking about operations, and we always start with this slide even when we talk about UTM, because for us, providing a service really only is valuable if it actually supports and enables an operation. And so we always have this operational perspective from the delivery service, and you'll see that everything we talk about is really operation-centric and probably operations first, and you'll hear that through our theme. There's some things today that will be repetitive, I think, from Andy and Gur as well, and I think it's really exciting to hear us all talk, I think, in very much the same way, and you'll see some frameworks that I think make sense across that. Gur touched on this at the end, but I think the diversity of drones and just today, and the multiple ways that folks are solving problems. We have actually a primary aircraft on there and a wing aircraft, and they look totally different. Their ConOps are actually variable and different. The business models are going to be changing. Everyone asks, is that a bird on the right corner? And no, that's actually a drone that flies around airports to scare away other birds, right? And it's something that you never really would have thought about. And so how can we create a system that has this level of flexibility to support these kinds of operations in various different verticals? A ton of them are listed at the bottom. We're not going to read them out, but you need a system that has that level of flexibility to support that. We all remember when the A380 rolled out and what it was like to implement the A380 in every air traffic control system in the world, right? Tens of millions of dollars, whole new ways of thinking about arrival and departure management due to the wake vortex. Imagine if you introduced a new A380 type of vehicle, a new flavor vehicle that wasn't really in the system before, every week, every month, every year. How would you support that level of flexibility? And I think that drives us to the federated model that you've heard us talk about today. Is not just us as industry saying it. We're hearing regulators say it. There's a few other quotes later, but the FAA themselves, right, said that the number and type envisioned the current air traffic system cannot cost-effectively scale to deliver those services, right? And so that's also led us, I think, to a lot of the experimentation and standards development and work that you've seen in the U.S. and elsewhere. So we're going to talk through these slides a bit. Ignore the box on the right for the first second, but there's three kind of key phases of this UTM ecosystem that we see. Right? If you start with drone operators or operations on the right, they need automation to help them do what they need to do safely and to help them do their mission the best that they can. You're going to see, and we heard folks talk about it quite a bit, but you also need safety through interoperability, right? How can those federated systems work together? What are the standards, the processes, et cetera? And we'll talk to that in a bit more detail. And then we'll spend a lot of time actually talking through the left-hand side, safety through oversight. How can we get authoritative, trusted data from the sources that have it? How can we have good performance rules and data sharing requirements so data is shared when needed with the aviation authorities, and we're also making sure we're meeting the expectations of those authorities as we carry out our support of drone operators, and then the validation and approval process. And we'll talk about it at the end, but I echo Gur's comment as well that it's not a one stop and done, it's a continuous validation and approval, and we do think technology can help here. But talking about this, I want to dive quickly through safety through automation of just a brief framework of what that is. Not going through all the details here, but there's many services that you can imagine that can help operators do their job safer and better. And I think there's some that we know about already. People have had long lists today. There's going to be services we haven't even considered. But automation will help reduce human errors, and it's a key part of the safety process. We heard Andy actually talk earlier today that automation is not a one-size-fits-all. It needs to be tailored to the operation. Each vehicle has different performance capabilities, different levels of automation. Each operation has different risks and needs. If you take a drone and go ahead and do an inspection of field, that's different than at an oil rig. And you also want automation to match kind of the SORA-specific assurance and integrity levels, all the pieces that go along with it. Some types of operations might require more reliable or robust automation, some might not. Again, the proportionality that we heard talked about a bit yesterday. this concept of approved providers, and we'll get there and talk about how that happens, but how do you have the operator know what they can get from a service provider? And how do they know that that is established? And a service level agreement, right, which we've seen throughout industry, is a key framework here. And it's going to be based on the operation, based on the vehicle, but it should define the uptime, the reliability, the type of service that you're getting, so the operator knows what they can take credit for and go to the regulator and say they can take credit for the automation that's helping with their operation and their safety case. It's also important because every vehicle, as we talked about, will be different, and so the SLA will probably also include some specific things of how you need to support that vehicle in that specific case. And the SLA construct and the flexibility of it enables us to address a lot of the diversity of drones that are existing, while still making sure that you have a high level of accountability on the USS side by the operator. And as we talk about what USSs can provide as automation kind of grows out, we want to make sure it's performance-based and not prescripted. Again, to support diversity, we know those performance-based requirements have to include security and privacy. The ASTM standard included security and privacy in it as well. But we're going to see that it's not just what you're going to do, but how you do it in a secure and again, data retention and management is a key piece. And then finally, it should be integrated with the USS's safety management systems. Having an SMS in place should be a must-have as we continue to grow and mature the USS industry, and the performance-based requirements and tracking of that should be, again, well integrated into your SMS. So this is kind of a high-level piece, but it gives you an idea of what safety through automation looks like and kind of what the expectation is between operators and the service providers as part of that. Now we'll dive briefly into the safety through interoperability. We already heard a lot about this today, so we're not going to go too much into detail, but interoperability is necessary. You know, full stop, I think we've all agreed to that. Standards are a key foundation for that. Not only does it promote global harmonization, but it actually makes it, I think, more straightforward for CAAs to provide oversight. If you have a standard, a CAA can make sure you're being held accountable to that standard and can be able to reuse that instead of coming up with new rules for how they provide this oversight. We do think standards should be the minimally sufficient interoperability, but we also want to make sure we're not locked into APIs, you know, for the next 100 years that we've decided in the next year. And so we do think there needs to be a path for innovation and evolution by enabling folks to go above and beyond the standard, still with good oversight, but again, enabling us to go ahead and evolve as industry and be able to continue to grow. We've once heard the term fossilized APIs as something that happens today in air traffic where you can't really update two APIs between two systems because they're both locked at a certain standard, and we want to make sure we can kind of break past that and not be fossilized in our approach as we go forward. And we already talked about this, and Gur talked about discoverability and data synchronization, but data consistency is critical in a distributed system, and it's best assured through standards, but it is something that is a solved issue, right? Having distributed systems is not a new concept, it's something we all live with every day, and so we'll be bringing that best practices, and they are part of it for remote ID, but it is critical for having data consistency in that system, and again, standards provides a good foundation for that. And again, standards are including things like security and privacy. Those are built in and expected in the standards that we see. And we'll make sure that that's handled in a consistent manner that makes it very obvious, not just for the operators, but also to the regulators and those providing oversight, what kind of mechanisms we have in regards to security and privacy. Folks have already talked about some examples of interoperability, but these are not new concepts. On the left, it's another view of the ASTM remote ID standard, but we have a world where you can have broadcast, networked, and even RC model aircraft all operating, some of them operating on different USSs, and at the bottom you can see multiple displays from multiple display providers, all providing the same exact data in a consistent way, and all that's achieved through interoperability. Right, the fact that you can download any app that meets the ASTM standard, and you can go ahead and see a precise and consistent picture of what's flying around you is a critical piece. And we've done that with over 12 different service providers to date, and that's really kind of a proven out concept at this point as the in parallel to the ASTM standard going kind of through its final ballot. On the right piece was the FAA UTM program, and this is 4 different service providers providing operations in overlapping airspace with various conflicts It also builds on the fact of manned aircraft integration that you're seeing here as that kind of bright red line. The FAA calls that a UVR, a UAS volume restriction, but it basically lets you know when there's an emergency helicopter or others entering that area, and you can see that there's a notification of it, and then it actually becomes active. As you see, it becomes bright red, and flight paths are planned around it. And all that was done via interoperability. There was actually nothing from the ANSP side except for the credentialing that actually was part of this process. And it's probably worth noting that I think everyone on the panel has also participated in the UPP as part of that. But these interoperability examples are here today. They're not research really anymore, and we're just getting to the path of how do we operationalize and productionize them. So safety through oversight, which is really, I think, one of the key things and key questions of this panel. How do we get to an oversight framework that enables the things that we've talked about and the diversity of operations that we've been wanting to support? Lance, not surprisingly, is a common theme here because it was probably one of the first models that we looked at. And it is both a case study in partnership and oversight. Andy gave a good example of it, but to summarize it in kind of another structure, is the CAA and the ANSP published rules and data. Here's the data you need to use, here's how you had to use it, and here's the process for getting access to airspace. And those were performance-based in terms of the outcome that you had to achieve for getting access to airspace, but they didn't tell you step by step how to do it. And there was also APIs for data exchange as needed to go ahead and provide that automated airspace access. And that process was a partnership with industry. It was a year-long process, and there was no RFP. No one paid for anything. There was no process beyond building out that cohort, very similar to what you learned about from a SUSI perspective from Switzerland earlier today. But it was really that partnership, and again, not a purchase of systems. And what they got is industry provided now. It's 14 different user interfaces supporting a range of operators from very simple to very complex. And folks have integrated all of that into their process. But the key improvement that you saw out of this was, one, you have automated access to airspace. What took 90 days now takes, less than 9 seconds. It's probably a second or two. You have much higher user compliance. The FAA just rolled it out to hobbyists. So not only are commercial operators now able to get automated access to airspace, but you have hobbyists who can do that as well. Some of them were probably flying there already, but now they have a compliant way to go ahead and do that. And we think compliance and bringing folks into this ecosystem in a safe, easy, and low-cost way is important. And the third was workload. The FAA had to process within 90 days all of these previously written approvals, and that workload, as drones continued to grow as an industry, took way too long, and it was backlogged. And so this automated access also removed the amount of time the FAA was spending approving things that could be done via automation. And so this was kind of win-win across the board as part of that framework, and it's kind of an initial case study in this partnership. But diving in a little bit deeper, what do we mean by data, rules, and testing? So these are actually cutouts from the FAA's specific LANC approval process. You can actually find it online. But this is an example of the data sources that you can download. How do you have the facility maps that you know which altitudes you can fly at? What are the national security restrictions? What are the airspaces? What are the stadiums? All the pieces that go along with that data. To the right is the example of the rules, right? What do you have to, as a USS, make sure someone does not fly in? That's the block kind of concept. And when do you have to make sure you inform the operator as the advise? And those are very clearly laid out, and they don't tell you, again, how the app has to do it, but the outcome is you have to either have blocked or advised the operator based on that rule. And then we go through on each platform, each app, a scenario-based testing process. For example, that you see in the bottom left, which says, hey, in this scenario, let's test this part of the requirements and go show that you can meet these rules in these kinds of ways. And that data plus rules plus testing makes you an approved provider as part of the process that Andy talked about as well. And we think this framework is reusable. We've actually seen it be reused, imported, and now working in additional countries. Going from the US to Australia, CASA had a challenge a couple of months ago, figuring out how to go ahead. They had an existing app that provided geo-awareness, and they were trying to figure out how to grow and replace it and improve it as they saw the drone ecosystem expanding. And so they had this approach to market that had these kind of concepts associated with it. They said, look, we want to make sure it's cost effective. We want to get out of the business of buying and paying for apps. We want to introduce a range of digital RPA services to support the safe integration of a variety of RPAs in the Australian airspace. And one supplier will probably not do it for all RPA users. And so that was a key concept that they had, similar to things that we've talked about. They also mentioned that its industry-developed solutions will provide some of this, and this was based on, again, learning from the Lance perspective. And then finally, realizing that they were not the first and they could learn, right, which was fantastic. They said, hey, other national aviation authorities, like the FAA, have been able to find a collaborative approach with industry, and enabling industry to provide some of the tools and processes for this. And so we saw this approach come out, and it ended up building out a process like this. So CASA is in some of the early stages, and we're working with CASA to help facilitate this, but getting to the spot of how can you get an approved provider process in place. And so this is each step of what you need to do to kind of launch this process. How can you go ahead on the CAA side, be able to advertise the rules, et cetera, and publicize it? And how can you make sure third parties can find it, have interest, and is willing to comply? One of the interesting things you hear when you talk to regulators, they're like, how do I make sure I have people interested? Even when you initially chatted with, even chatting with Australia and others, they were like, we need to have at least one, but how many will we get? And I think when you're seeing it around the world, and even with, in the US and elsewhere, many companies want to actually provide services here. It is a very exciting and comprehensive market to be in, and so I think there is strong demand. And so one of the things we do want to encourage as you think through this is that you can, you will not have just one, you will probably have 10 or 14 as the FAA has, or 20 by the end of the year, and you'll have to think through how you do those processes. So first publicize, then there's an application process to go through and say, hey, based on the guidelines, how can you show that the applicant is willing to go ahead and provide that they can provide those services, and perhaps some level of application fee to the CAA. It doesn't have to be a lot, it could be a little to cover the costs, but that's really the only spot here that you're really looking at any cost recovery. On develop and integrate, you want to go ahead and enable folks to have access to a development platform, so people can develop and iterate on the process, and then the right, enabling third parties to develop those capabilities in association with the rules. And then after that development period, and you can define that as a CAA, what is the process for assessment? So we talked about testing and scenario-based testing, and I think we're going to talk a bit more about automated testing as the world moves forward. But you also need to have the third party go ahead and prove their compliance to standards, compliance to tests, et cetera. So there is that assessment process, which is key in here. And then going through those steps and launching those pieces, you can go ahead and become an approved provider. So on the CAA side, you can go ahead and have access to the services that you need, whether it's the ANSP services or additional services as part of it, and you should go ahead and be published as an authorized provider. And then on the right, you can actually move from a test instance to an operational instance, as we all expect to see. The key part here is all those steps actually can be done pretty quickly, but this ongoing piece, I think, is the overall challenge for us as an industry, right? How do you have it not be just once? It has to be, I think continuous was a great term for it, and that really can only happen with automated testing. And so many of the processes we start with today are manual, but we'll continue as industry to invest in some of that automation process. The other key piece as part of oversight, we think, is the SMS, which is a great framework for oversight today, and another key piece that we should be moving towards as USSs in this industry. But this process can be repeated per country and mirrors a lot of what the FAA has done, but you can see that this can also work across multiple services. So how did this work in Australia? We were able to see the start of an ecosystem for drones within 3 months. So literally starting from 0 to 3 months, we were able to establish data, rules, and testing to be an approved provider. We created a list of required and authoritative data. What was really interesting from an Australia perspective is this required more than just aeronautical data. In Australia, fires are a very hazardous situation and need to be avoided. And so as part of that, it actually included the support of fire incidents, which came from state fire feeds. we had tailored definition of rules per flight rule. So in Australia, there's 3 types of flight rules. There's recreational, there's commercial excluded, which is generally less than 2 kilograms and within standard operating conditions. Then you have the REOC, which requires an operator certificate. And the rules and processes in the data plus rules plus testing was tailored per flight rule, so you knew what you could approve for each, because those with an operator certificate perhaps had different or access than their recreational side. It included initial onboarding and testing procedures as part of that process. And there was already, through our work with them, a first industry application that went through adhering to the process. So they have at least one CASA-verified drone flyer app. That was our work done in partnership with CASA. But what's more exciting is there's more applications, more other CASA-verified apps that will be coming. They're opening up this ecosystem to many other players, and others will be coming through in kind of a cohort-style way to go ahead and work through this process. But just really thinking about, we talk a lot about years and decades, but how can we do some of these things in months to really open up these ecosystems? And if the FAA can do it in a year, and if Australia can lay a foundation in 3 months, I think that's something we can all find a way to go work through across the various countries to help make this happen. I think us as industry are willing partners to help share our advice as part of this process too. One of our final pieces is a consideration for an ecosystem. What do we want you to think about as you're like, hey, well, I'm excited now about having an ecosystem. I'm excited to support the diversity of operations that we've seen today. I'm excited to make sure that UTM can support SORA and the breath. What are some things to think about? The first is don't build it, honestly. Oversight it. Have a process where you can go ahead and stay on top of the ever-changing technology. But that world is changing. It's changing faster than you could probably get RFPs out to go ahead and manage that change in technology. And so, and it's going to become increasingly more expensive to go ahead and provide these services in this ecosystem. So we really recommend, again, oversight process over building it. Another consideration is don't be overly prescriptive in how you do it. It's easy for us in the aviation community to go ahead and want to talk through the specific UX experience, even to the color level or the text. But when you do that, it actually does not only stifle innovation, but it takes you more to a more manual approval process as part of it. The second is the performance-based rules need to be concrete, and they can't be subjective. And so that's something that we've seen as we go through is writing clear performance rules are hard. But that's something that as industry collaborates with ANSPs and CAs, that's something we can work through, but we have to make sure and be aware of subjectivity. And then the third is business case and products will evolve, right? Nothing is static in this industry. And so the more performance-based and less prescriptive, the more, I think to quote Airbus, future-proof you can be in this process. On the right-hand side, these are kind of very straightforward concepts. Do leverage standards. I think that is something where you're seeing tremendous work, not just by industry, but with regulators and ANSPs in the room, helping come up with standards like remote ID. And so please leverage those. I think you should also consider commitment to interoperability, but also open source software. You're going to see industry collaborate in ways that we traditionally don't think of from an aviation perspective, and having that open source approach is also a very critical way, especially when there's any common pieces, to go ahead and leverage that compliance to standards in an open way. Do expect to learn over time. You're not going to have every answer up front, and you need to have the flexibility to do that. How do you adapt to a new vehicle type, a new app, a new service? These are questions that you need to ask. And again, if you go back to the previous slide of the processes of what it takes to become approved, you can continue to learn and do that and update your rules and data and testing as you learn over time, but don't expect to have all those answers up front. This industry is quickly changing and expect to be learning. And then the final piece is do focus on automation and ongoing validation. That is a key piece, but for us to really be successful as an industry in the changing world, continuous validation is a key concept. So with that said, I will leave it at that. Thank you all so very much.
Thank you, Reinaldo. Very, very interesting presentation. I think you summarize what we haven't discussed here the whole morning. So now we have time for questions. Let's see what we have here. Right from the top. And this question is about we have extreme visions in this panel from different approaches. See the question. of course, one build on the decentralized and another one in the centralized approach. So the question is how and when we will converge to a harmonized vision. Should we or should we not? Should we have two different visions? Or do we expect individual states to choose and implement their own vision, which might lead to problems for cross-border interoperability for UTM service providers and UAS operators? So this is open for anyone from the first session as well to answer. I'm gonna take.
Perfect.
Speakers in the morning to come to the stage, please.
Pass this question to Switzerland because I think they have a really good quote. I'll lead it off as Benoit is coming up, but it's what I've heard folks say is what, especially with Swiss folk, is what must be centralized should be, but what can be done by industry should be done by industry. And I think that's a very interesting philosophical approach of how can you have something that is that level of flexibility, that level of openness, and I think if we can take it from that concept, we'll have a much more resilient approach over time. I was going to say.
Well, absolutely. I think agreeing on the vision, again, it's important that we have the very high level ideas I mentioned in the morning. I'm not too concerned about the rest because nothing survives implementation, right? You can have the vision you want, the hope you want. At the end of the day, it's when we get the standards, it's when we get the tests that we see what's happening. And I'm pretty sure, you know, what I see happening over and over again is that you see everything converging because there are clearly solutions that are better than others. Whenever we'll have solutions that are equivalent, well, okay, then maybe we'll have that. But honestly, this is not something that I'm afraid of today. I really think that the process as it is working. So,
just to follow up quickly for that, I think what regulators, from discussions with regulators today, they want flexibility for a world that's kind of unknown and changing. And so I do think no matter what you want to pick in that scale of solutions, how do you maintain the most flexibility to react to this space? And I think that is a key thing to optimize for. And I think if you ask a country to pick something that is centralized without the option for federated and standards coming, I don't think you have the full set of flexibility that you want as a regulator to adapt over time.
Good morning again. I think the question finds a simple answer. There won't be a single model applying all over the world, for sure. And probably there won't be, as I tried to explain this morning, there might be solution that should be applied differently, service per service. So I don't think that neither the centralized nor the federated solution, but that's my personal vision and also a position which is shared between Italian regulator ENAC and the Italian Air Navigation Service Provider INAV. The federated solution right now is not the most appropriate for specifically a number of basic use-based services that should be provided universally through the entire airspace to ensure the market takes place. And of course, there will be a number of drone operators and use-based service providers which will leverage upon it, provided that the market flourish. And once the market will flourish, there will also be room for several use-based service providers providing a vast number of different services with add value for operators. And definitely the value probably does not be in the registration or in the electronic identification on tracking, which would probably be safety of life somehow services, at least on the perspective of the regulator and especially in the perspective of the Air Navigation Service Provider. The value will be maybe in very vertical solutions for designing missions, or in high-level details maps, or micro weather prediction services, which will really help drone operators to plan their missions in a better way.
Okay, our point of view as ANSP is very similar to Cristiano. As I put in my presentation, we think that the critical services should be in a central entity, national, very neutral, and to hold information and the specific and sensitive information to be in a neutral platform and not in the hands of USPs providers. That's a summary.
If I can follow up on the question, then how about the interoperability?
Maybe I'll connect both these. We used to have a telephone network in the past that was centralized, and it worked. That was the initial, like every telephone, there was a national telephone company and central switches, and at some point it stopped scaling for us. So I know there's a lot of concern that the ANSP's regulators, authorities, etc., will have to give up control, give up capabilities to administer the airspace that they have, that they're required legally to control. What we know today, looking at the telecom industry, is that the telecom regulators do have the control without the requirement to operate a lot of the very expensive sort of mission level or core level services. So, I mean, I would ask that we get inspired by technologies that include technologies outside aerospace that may solve problems that we will face in the future. This is sort of a new problem because of the scale of drones and the diversity of systems, and potentially requires us to look at new solutions. I think we sort of got lucky that this is not a new solution, that federated architecture is actually a very old solution. It's over 30 years old, and it's used in multiple industries that are sort of life-critical, mission-critical, 911, right? If my phone can do a 911 call, then that's a life-critical safety application. So as an industrial developed world, we have experience in architectures that are at least should deserve the opportunity to prove or disprove that they can work. I think that the key point on interoperability is guaranteeing that any system that complies with the standard can operate in any location that implements the standard. And that's sort of then the specific flavor that you choose. Is it a single entity per country, or is it multiple entities with some delegated authority? That's sort of an important secondary decision. But without interoperability, we don't even get to make these sort of decisions. So step one is make sure all systems interoperate. Step two, we can talk about the merits of one architecture over the other architecture.
Thank you. Another question is regarding the communities. What approach every entity, if you have any, with the communities? Are you approaching the communities and to raise awareness and get the acceptance?
So as Wing, we'll talk a little bit more as an operator, honestly, than a USS. Communities are essential to the work that you're doing. When you have a drone operation, it is in that community. And for us, we are, since we're providing kind of services in that community, we're part of it. But I think from the perspective that we've learned through that, I'll share some examples. We had the most optimal flight routes, and everyone thought that the number one business rule you'd want to have as a drone operator is the optimal flight route. Well, we had an optimal flight route, and we also had a customer who really loved delivery, and so would order again and again, and that optimal flight route was over the same other parts of the community at that time. And so one of the things we learned from that perspective is that optimal from a performance standard is not optimal from a community standard. And so we've actually changed the route. They're now more randomized, they're occasionally suboptimal, but they're now more community optimal. I think that taught for us that corridors are not a good idea, because you're going to then have that focused traffic in a certain area that you're dealing with. And so I think there is this key thing as we look at communities and how to engage with them, that it's another learning process that you're going to need to be flexible on and change. And you don't really know that until you are in that community. But for us, even just the learning of route planning, there's a different community optimality from that than a specific path optimality. And that business case and that approach and how Wing as an operator wants to solve that will continue to change as we learn. And that's part of, again, the flexibility that we need as we go forward to figure out how to best address it. So that's one perspective I would give on community.
Yeah, there's definitely another stakeholder that we all know, and it's probably not represented here, is the local law enforcement. They are absolutely critical. I mean, local authorities, they are the one talking to the public, explaining what happens. And again, I think we had a very good experience in the remote ID demo with the local Geneva police, where they're really, day after day, you know, they're answering the phone calls, what's happening, and so as long as once they become able to explain what's happening, what are drones operation doing, then you see also a much wider public acceptance. So it's really critical that we give them the tools. So remote ID is one of those, right? And typically there's a field in remote ID that I really like where the operator can add on a voluntary basis what they're doing, or they can add a website, they can add a string. That string is key because it creates transparency for the public, for law enforcement, and you really see something changing. It's a very simple thing. It's one field, you know, 40 characters, I don't know how much there is, but that changes everything. So, you know, I don't think we need to go to very complex solutions to that, but it adds up.
Just want to build on this two very good thoughts of Ronaldo and Benoit to shed light on one aspect that we, I think, often forget, because a federated model actually allows different solutions for those communities. So the law enforcement officer doesn't have to use the one system. He can actually choose between maybe 10 different ones. There's a price competition, which is good for the taxpayer in the end. And the innovation that this enables, because you have to be innovative to be successful in the market, of course also leads to safety innovation. So, you know, this manifold drones, the hundreds of millions of possible designs and operations, if we don't allow for innovation around the safety of those operations, then I doubt we'll ever make them safe.
Let me see here. We have several. I have to pick one because I only have time for one question. Let's talk about approval process. Who should do this? Considering the CAAs are already overwhelmed with the work they have to do, can this be assigned to a qualified entity? Can someone do this on behalf of the CAA? Who should be establishing the approval criteria?
I think yeah.
Sorry.
You want to go?
Sure, very quickly. I think the first question, it goes back to interoperability and standards, right? So if everybody implements the standards the same way, then you already reduce the bulk of the complexity of approvals. You know someone is in compliance with the technical performance requirements. And now the approval process for the local approval process at the country level, the state level, etc., is really about the business case and data retention, sort of the local concerns. Where most of the complexity is, I would say 99% of the complexity of approvals and certification are the standards implemented correctly on a continuous basis. And that almost by definition, once you have international standards, is going to be done once worldwide as opposed to on a per state basis. So I think that's a huge cost saving.
Here I think it's pretty simple again. You know, it's a CAA duty, right? So that's it. That's already, you know, like when we talk about USS authorizing, you know, USS don't authorize, right? They can get something that the CAA decide and facilitate, but at the end of the day, and that's why we're pretty clear, you know, it's still a state duty. And so here it's the same for any approval. First, the states must learn. So that's why for us it's very important that we start by doing it. Over time, you learn what you can delegate or, you know, automate. But I think it's very important here, talking to other regulators, that, you know, at some stage you must build the knowledge internally, and then you can go ahead. So I would be very reluctant that to anybody saying, I know how the approval process should go now. I think, again, we need to build the process to get the data and then decide. And so that's, you know, pretty much the same as I've been explaining this morning.
Thank you.
I was going to say the two aspects that I think will also help here is one, as we move towards more automated and continuous approval processes and validation, that should reduce the burden over time. So it's done by, you know, electronics and not a human in the loop. And so again, we need to get out of a human-centric approach for that as well. And I think this is an opportunity for Drone Enable. You have regulators all across this room who are working on how you do approval processes. There'll probably be more next year. I think there'd be a great topic to think about how folks can share their learnings around how they've approved USSs so far. And I think ICAO has a great role of pulling in that thinking and sharing that knowledge so everyone doesn't have to reinvent or rethink the same questions that each individual country is dealing with.
We don't have more time to any questions. Please, the questions that we have here, we are going to send to the panelists, so they're going to be able to reply to you, so you'll be answered. This is a call for ICAO coming here from the panelists. I'd like to thank you all for your participation, for also replying for the FIR. Please join me to thank the panelists for today. So I have a few housekeeping announcements. This afternoon we will return with a single stream. Probably is going to take the divider. We will start at 1:45. The speakers for the next session are requested to be on the stage at 1:40. And I'll invite you for lunch, who is sponsoring today by DJI. Thank you very much.